Hello everyone and welcome to this video. This is the second video in our Android to Compose Multiplatform series or Android to Kotlin Multiplatform series, in which we will be converting this Android app to Kotlin Multiplatform and then Compose Multiplatform. So in the previous video, I gave you just an overview of how the code is structured, but let's now dig deeper into the code base. So let's first go to the design system and scroll down a bit. Okay, so here the design system module only has all the compose related dependencies, only the UI related dependencies. It's compose UI, material, navigation, compose, animation, foundation, and all those things. And if I go to the actual module, so it has two components and theming system, typography, and extended spacing, composition local for managing spacing all around the app, then extended shapes, which as the name suggests handles all the shapes all over the app. And then there are two components, one is the app bar and there is a text input field. Okay, that's it, and that's all the design, all what the design system module actually has. And then we have core, and inside core we have the data layer, then a domain layer and a presentation layer. In the data layer there is a converter for the local side, which is managing the database entries, and then a data access object for room, an entity class, and the actual database. And there's not. And if I go to network, there is one movie DTO in the API which has the base URL and the number of items per page, and Retrofit interceptor. Then domain we have all the local data module that provides database related items, and the network module, and it provides the OK HTTP client, JSON, and Retrofit instance. And it has a model which is movie domain model, some collection functions, and an async image. And inside feature search we have again data, remote, repository for getting repositories, movie service for accessing that API call and getting the data, a TI module for movie service and movie repository, and that's all that we need to know here. So in this video we will be migrating our network layer to shared code so we can access this all over the app. In order to do so, let's first go to project and now create a new module which will be the shared module. And although there are multiple options, but the one that we need here is the Java or Kotlin library, because at the end of the day every shared Kotlin module is just another library module that you will add to your app. It can be just a small module that manages analytics, or it can be the whole app logic as well. So it depends. If you are adding something new to a brownfield project, or it's a completely new greenfield project and you are starting to write code in the shared code since the start. So we are migrating our network layer, so we will go step by step in migration. So let's first create a shared module for our network layer. So let's just name it shared, and the package name is fine already is okay. So I was trying to just play around with this. Let's delete the shared module and go back and create the module again, and we'll call it shared. Package name is fine. We will delete this main class later on, so that's fine as well. And Kotlin DSL, and not the Groovy one, Kotlin DSL, and click on finish. It will create a module and sync your project. Okay, it's still syncing. Then let's go back to the Android side Okay, let's wait for it to sync. Okay, now it has synced. Let's remove this. We don't need this Java block. Let's get rid of this. It is not a Java library. Get rid of this as well, and get rid of this. So for this Kotlin module to be a Kotlin multi-platform module, we need to add a plugin called the Kotlin multi-platform plugin first. So for the sake of simplicity, I have already added it inside the plugins in my lib.cat version, or the Gradle, whatever this is called. Let's go to project level Gradle file and add the plugin here first. Libs.plugins.Kotlin multi-platform, apply false, and let's go back to shared, and now we can add the multi-platform plugin here. And now let's sync the project. And now the project is synced. Now we can access a Kotlin block here, and we can add the so-called targets. So what are targets? Targets are all the different platforms that you want your shared code to be able to compile for. For example, if you want to share this Kotlin code to JVM or Mac OS or iOS, Linux maybe, then you have to add that target to the top level here in the Kotlin block. I've added the Android target first, then I can add all the iOS targets. Previously, it was possible to just add this iOS target and it would cover all other targets, but now first iOS x64, iOS ARM64, iOS simulator ARM64 for running the app in simulator, and then we can access the what's called source sets. And so what is a source set? Understanding source set is very important for Kotlin multi-platform development. So what is a source set? A source set is a combination of files that make a particular target to work properly. For example, in Android, we have different build flavors. There can be a QA flavor, there can be a dev flavor, and then there might be a UAT flavor of our app, or maybe a paid and unpaid flavor of the app. So all the files that help us build that particular flavor, so there are files that help us to build that particular flavor, and that particular flavor is actually a source set. Okay, so here all those files that compile together and make the shared code accessible for that platform is a source set. I think if that's not clear, you can head on to documentation and read there as well. So the first source set that we have is the common main. The common main is where all your shared code resides. For example, if you want to add a library that you can access in, or you want to access in your common code, then that library would go here, as the AI is suggesting the KTOR client libraries right now. So all the libraries that are Kotlin multi-platform compatible, those will go inside the common main. Okay, I have already added the KTOR KTOR related libraries in my version catalog, so we can access and add those here. And plugins KTOR .core, this .KTOR serialization.json, serialization, KTOR content negotiation, and I think there's only one left, or maybe nothing left. Client core serialization, and we have logging. Yeah, so we have logging as well. So in the start, we define two targets. One is the Android target and then the iOS target. But here, and for Android target, if there are some dependencies that are not available in common main, or there is some library that you want to use inside your common main but is not Kotlin multi-platform compatible, then that specific library will go and inside the Android main, and then we can make a bridge between the common main and the Android main to make it work inside the shared code. We will discuss this later on, so let's just be with me. And we have KTOR.Android. This is the KTOR HTTP client engine specifically designed for Android. And now, similar to that, we can use native main and add the dependency for libs.ktor.ios. So here we have iOS targets, but why did I use the native main? Because here, if I'm targeting Android, I just wrote Android main. Then what native main? So native main is the top level kind of source set, which then includes all the Apple targets. So if you add native main, it will then be accessible in macOS, in iOS, and other Apple related platforms. So the KTOR dependencies are here. We also need the serialization, Kotlin serialization plugin, and we also need the Android library plugin, because at the end of the day, again, it is just a library in your Android code, just like any other module that you might have been adding to the to your Android app prior to this. And let's click on sync. Okay, so there are a few issues. Let's see what's wrong here. Okay, so it's, as it is an Android library, we need to add the Android block as well and define a namespace. It's com.example.shared. Let's click on try again, and it should work properly now. Okay, yeah, our sync is successful. If I go to shared main, now you can see the Apple main, common main, iOS main, and then the native main. And here we have our default code that that was generated when we created this shared module. Let's go to project view and close this and open the shared. Okay, we need to delete this main, or let's just get rid of source as well and create a common main. Oh, it's not a sample data. Go to directory and create common main. So now we have common main, and now we are targeting Android as well, so we need Android main as well. Okay, now Android main is added, and the last thing that we need is the native main. Okay, now we have all what we need. Now let's create a package hierarchy, not a class, a directory, code example, and the last would be shared. Okay, now I'll just go ahead and create a Kotlin file named platform. So we discussed that we can bridge the gaps between the common main and other mains, like in Android or native or iOS or Linux or Java, basically JVM. We need to make a bridge. So how do we implement that bridge? So we create something called the expect function. And this is how you create an expect function. So if you notice, I haven't given it a body, and if I click Alt and Enter, then it gives me option to create the actual functions in these mains. Let's get rid of this and let's understand this first. So what is an expect function? Expect function can be considered as an interface. So what you do regularly is you create an interface, and then you implement that interface and create a concrete version of that interface using the implementation method. So the interface does not contain any business logic, or it does not contain a function body for all of its function that it has, but only the concrete classes that actually implement that interface give the business logic or the body to that function for that particular class, related to that particular class. So similar to that, we create expect functions. Inside our common main, and then we give the actual implementation of those inside different platforms. For example, UUID is generated in different ways on different OSs, right? On Android, there might be some different logic. On iOS, it might be something different. On web, it might be something different. So for all these different implementations, you do not get UUID inside the common main. You have to get that from that specific OS. And similar to that, we can get the platform name of that particular OS, or the platform that the app is running upon. So we add the actual implementation inside Android main and native main. And if I add the actual functions, okay, I'm inside the native main, so I'll just return native from here. And let's go back and go to the Android side and write Android here. So we currently don't have an iOS app, but once we have that, we can then test this as well. But for now, we will just focus on the Android side and complete that first, and then we will slowly and gradually we will go to the iOS side as well. So inside app, I'll go to the main activity and comment out this navos for now and create a text composable. And here I can call the cat platform. Okay, so I didn't add a shared module to the build cradle of our app. Go to the app and scroll down, implementation and projects dot shared, and sync it. Go back to main activity, and now we should be able to access that get platform. And now if I run the app, okay, there are a few issues. What's the issue? Let's scroll up with 2 failures. Okay, we need to add the compile SDK inside our share modules Android block. Compile SDK, let's make it 33, sync again, and now we should be able to run our app. Okay, so app is now, okay, there are a few issues in this. What are the issues? No, nothing here. Inside shared. Okay, once it fails, we will be able to check the issues. Let's pause this a bit until it's compiling. Okay, so we have inconsistent JVM targets. So I'll just go ahead and pause the video and bump it up to 17 for all different modules, and then I'll come back. Okay, as you can see on your screen, I have moved all the source compatibility and target compatibility for compile options to Java version 17. You should be able to see Android, but let's go to main activity and change the style to maybe material theme dot typography dot h1, so it's better for visibility. Okay, what's the issue? Okay, no, I'm here. No, yeah, you are lying. I don't need this here. Okay, now our app should compile and show Android. Yeah, so it's there. So again, if I go back to project, shared and platform, so get platform does not have any implementation, but it actually gets the implementation from the Android main. So we can then bridge all those functionalities that the common main does not have, but the Android main or the iOS main actually have. So we then can bridge those functionalities using the expect actual methodology. Okay, so now we know that our shared module is working fine. Let's go to core maybe. Yeah, we need to go to core. Let's go to core here and Kotlin Java main, and we need to go to data and network. Just copy this and go back to shared. We need to go to the common main and create a new directory called data and paste this here. Okay, one thing that you should notice here is that I didn't cut these files from core, but actually copied those here, because you would when you are migrating to KMP or just testing this around, you would never want to hurt your existing functionality. You don't want to break your existing working app. So it's better to copy and paste these files rather than cut and paste and break the whole app, and you won't be able to test anything that way. So let's do some requirement gathering. So here we have the serializable annotation working, because we have Kotlin serialization in our dependencies and inside our plugin as well. We need to remove these what they say, call it whatever those are. We need a movie entity, and let's just convert it to map for now. Okay, convert it to map. We need a movie domain model. Okay, so there are two things that we need here. One is the movie domain model and the other is the entity. So if we go back to core and look at the movie entity class, it is actually an entity for room database, and we are not migrating that room database as of now. So what should we do? This should have been taken care in the start when designing the app architecture. This function should be part of movie entity, not movie DTO, because this doesn't make any sense. So let's go back to movie entity and paste it here. Okay, so movie DTO, let's not fix this now, or maybe we can, so it doesn't hurt us in compiling our app. Then we have certified database, we don't need it, but one thing that we do need is the domain model. Let's copy this. Again, we are not using cut, we are only using copy, and create a domain package, and inside this paste the models, and now we have the movie domain model as well, but we don't have the immutable annotation as we haven't added the Compose plugin. Let's get rid of these as well and scroll down. Okay, so we have simple date formatter here. Simple date formatter is a Java library, and we cannot use this in common main. In common main only Kotlin works. It does not know anything about Java. So we will fix this later on, but for now, again, how will it be fixed? there are two ways to do this. The first way is to use a Kotlin multi-platform compatible library for doing this, or we can use the expect actual functionality to pass this state inside Android main and get the pass state back using the actual functions. But for now, we will just return input date. Again, string format, not working in Kotlin, but for now, we will just convert the incoming number to string. And let's add a to do here so we can remember that we need to fix this later. Okay, and now going back to our model, moving to main model is here, so let's import it. Okay, let's make it map again. So no issues. Our movie DTO is fine, movie to main model is fine. API, nothing needs to be changed here because it is only providing the base URL and paging size. What about interceptor? So interceptor is a retrofit thing, so we cannot access it here and we don't need it here because we will be migrating to KTOR. Let's delete this. Okay, let's refactor this and call this remote. And now we need a Kotlin class, remote data source, and create a class here, and the class takes 2 parameters or maybe just 1. Let's see if we need another. Okay, so private HTTP client, but in order to pass this here, we need to first create the HTTP client. So before that, we need to create an expect function, get KTOR engine. If you remember in the start, we added different dependencies of KTOR engine for iOS and Android. So how we are gonna break those? Again, using the expect actual functionality. Click Alt Enter, add missing actual functions. We need those in Android main and native main. Okay, we are in the native main. Then we can return Darwin, which is the client engine for iOS side, and then we can go to Android, and for Android we can either use OKHTTP or this Android. So we are using this, not OKHTTP. It depends what you like. Now we have the HTTP client engine, and the second thing we need is create HTTP client. You can just simply create it like this, or you can also add some customizations here. So KTOR works with plugins. If I go to the build.gradle file here and scroll up, this KTOR serialization is a plugin, JSON is a plugin, content negotiation is a plugin, logging is a plugin. There is whole KTOR plugin registry available where you can go and check all the plugins that you might need for your HTTP client. For example, sockets, for example, HTTP call validators, default headers, whatever you want. Okay, so let's go back to our shared main and create the HTTP client. So I want to able to log my network requests. So I will, okay, thank you AI, and log level logger dot simple and logger level dot info. So I am using this install function to install a plugin inside HTTP client engine, HTTP client, which is the KTOR client, and then I can access all the different functionality that this logging plugin has and set it according to my needs. Then the second thing that I want is to install content negotiation, and I want JSON content negotiation. Let's create I think I have already done this in where I think it's in feature search and DI modules. Okay, no, not here. Let's go to core and find it. Local data module, network module. Yeah, here it is. You might be thinking why I'm not using DI, because first we have to test this client engine, then we can move to using DI. So JSON is here, logging is here, content negotiation is here. What else do we need? Let's check in my other project. Let's do some cheating. HTTP client, and we don't need timeout, not validated. We already have content negotiation. Okay, we don't need anything. So we have the client engine, we have the HTTP client. So let's make an API call here. Let's create a suspect function, get movies, and not here. So the AI is not always right. I hope it is, because it makes our life a lot more easier. And then, okay, let's understand the structure first. We have the HTTP client, and then using the HTTP client, we can call different functions. For example, I'm calling get here, but if I add a dot, and then we can use get, we can request, then we can use post, we can use put, and everything. As simple as that. No nonsense like in Retrofit. And here I can get content, call status, version, request time, or the body. Inside body you can tell which return type does it have. So our return type would be movie response, which is actually serializable, and we are using Kotlin serialization. Kotlin X, I call it Kotlin, but it's Kotlin X. Okay, we have our remote data source here. Let's go to main activity and test this. I'll just go ahead and create a launch fact here. I'll just pass unit val response, and response would be what was the function called? Remote data source. Okay, we are not returning anything. Let's return the body here. I guess there should be one issue here, but let's check if we can access this get movies function. Okay, yeah, we can. Then results dot as domain model, and now we can print the response. Okay, let's run our app. Let's check build is successful. Let's go to logs. Yeah, so we were able to call the API, but it would not be successful because I didn't provide the actual API key for this. So at least we now know that our HTTP client is working fine. Okay, so get rid of this and let's organize our code a bit. Go to remote data source. What does it need? It needs an HTTP client and does not need a KTOR engine. Let's move this get movies function inside our network source, and I think we are done with this. Yeah, Okay, now we need this network source to replace the already running retrofit API that we are using here. So inside the movie repository, instead of this movie service, we will inject our network source. It's called remote. Oh, I haven't added the share module to feature such, or maybe I should first add it to core. Let's see what does core have. Code converter. Okay, yeah, it has all the models. Let's go to core, scroll down and add our implementation here, projects dot shared, and remove the shared from the app level. Let's sync our project. Okay, now we should be able to access. Okay, now that we have the movie TTO inside, or maybe let's just it's a tough question. Let's just delete it and see if we get any consequences. Remote data source. Oh, I deleted the wrong one. And delete directories and Command Shift C here. Let's go to core. And from models and interceptor, we don't need the API, we don't need interceptor. Delete this from here, and inside entities we should now be getting some errors. Yeah, so we have the movie TTO. The updated movie TTO is from our shared code and it's fixed. No issue here, no issue here, no issue here. And now go to local data module, no issue here. We can just get rid of JSON here. We don't need the retrofit client as well, so let's get rid of all this. Now we will create some new provides, and these will be singletons. Fun create, or it should be provide HTTP client, and we will just call the create HTTP client method here, and then we need to create the remote data source, which is going to be singleton as well. Provides remote data source, and it will get HTTP client, which will be injected inside our remote data source. Okay, we need to do something here to access our HTTP client inside core. We first need to make it an API, and I don't exactly remember if we need to make a HTTP client in shared as well as an API. Yeah, we do need that. Let's go to shared and replace implementation with API and replace these. Now sync. Go back here. Okay, now we should be able to access HTTP client, remote data source as well. Now our DI is fine, and we don't need this movie to main model as well. Let's delete this. I use utils, no need. Okay, now our core is fine, and nothing's wrong in core. Let's go to feature search because it should be broken. Yeah, it's broken. Yeah. Feature search, we have core here. Let's go to movie repository. Instead of movie service, we will use our remote data source. And let's import movie domain model from our shared code now. And it is returning a flow. We don't have a response to it is successful for now. Okay, so let's get rid of this. Get rid of page as well. We don't have a body. We only have results. And then we don't have pages. So let's hard code one for now. Or we actually do have page, so result.page, it has entity, it has domain model, and we don't have exception messages, so let's write something's wrong here. Okay, and local movie is empty. So we remove the if from here and get rid of that else as well. So this is working fine now. The key is that you never actually rewrite or move your actual files. You make a copy of those, and once those are working fine, then you edit the other functionalities that are using in those files, and it would be much more simpler as compared to moving those files and making your the whole project broken. Okay, movie repository. No, we don't need movie service. We need remote data source, and it should work fine now. Okay, nothing wrong in movie repository. Nothing wrong in implementation. What about remote? We don't need this remote now. Okay, let's get rid of this. Inside modules, no need to create movie service. Fix the imports as well. Optimize imports. Nothing wrong here. We will be using this result class in a better way later, but let's just leave it for now. Okay, we have the details screen, and why is it complaining? Okay, let's check other movie view models. Okay, the issue is in the view model, that's why. Movie domain model, it's fixed now. Details screen should be fixed as well. Size screen should be fixed. Okay, we need to import movie domain model from here. Fix the imports. This is quite tedious, but it is what it is. What about components? Yeah, we need to import movie domain model here as well, because movie domain model is no longer in this module, but it is in the shared code. I guess everything should be fine now. Let's check our main activity. Yeah, we need to uncomment this navhost and remove this text. Oh, there's something wrong in the imports as well. Okay, get movies is no longer accessible. Let's see now if, okay, there's still a few issues that we need to address. Okay, just adding some imports. Let's run that now. API of paging size. API is inside shared main. Let's wait. Our app is not launching. Let's see if it is working fine. Okay, we need to add a correct API key here. Let me copy it from my other project. I'll just, oh, you have already seen it. Let's just post this. Okay, so now I have added the actual API key, and now rerun our app. Oh, there's still an issue. Why? Let's see what's the issue. Okay, Kotlin missing field exception. 404 page not found. Okay, the issue is with our URL. Okay, let's fix it. Endpoint. So I'm just copying the URL from my other project so we can access. Let me just pause and add the correct URL. Okay, so now I have added the correct URL and the correct API key. Let's rerun our app. And it should, okay, still not fine. Let's see what is the issue now. 401 unauthorized. I think there's something wrong with the API key still. Let's just pause it again. Okay, this time I have created the page URL and API key as well. Let's rerun our app, clear the logs, and hopefully the third time we will be lucky and we will get some data. Okay, not again. Missing field exception. Okay, so the issue was very simple. We were using post instead of get. So let's make it get and rerun the app. Sometimes a very small issue is there and you cannot see it. Now we should be getting our movies. So we are running our old TI settings with Hilt. We are running our same database, same navigation, everything is same, but we have only migrated our network layer to the shared module and it is working perfectly fine. So this is the app, it's working fine, and click is working fine. Data is loading just fine. So now we have migrated our network logic completely to the shared module and it is working perfectly fine. And this is how you can actually, okay, so now we actually need to get rid of this client and use the HTTP client that we are passing through Hilt. And let's check if it is working fine. Yeah, it's working fine. So this means that our TI is working completely fine. So this will be all for this video. You can try this out. You can go to the master branch. I will make this a separate branch, not the master branch. So we can, so you can actually get the exact branch for the exact video. So this branch will be the network layer branch, and you can go and first check out the master branch and then try yourself to move to migrate the network layer to the shared module, and then you can also compare your code with my code just to get things moving if you get stuck. So thank you for watching. This would be all for this video. In the next video we will be migrating our room database to the shared side as well. So I hope we will meet again. Till then, take care, goodbye, and please don't forget to subscribe and click on the thumbs button. Thank you.